Hey everybody, this is Larry. This is me going over Q4 of the weekly contest 304, longest cycle in a graph. Hit the like button, the subscribe button, join me on Discord, let me know what you think about this poem. This is the fourth, this is another Q4 that has been kind of plaguing me lately, and I got multiple online answers on this one. You could watch me solve it live next, where I just make very silly mistakes. I think this one is a very well studied problem, but even if not, you just have to be really careful. There are only two things that, well, apparently, if you're according to me, there are more than that, but it's just about keeping track of things. And I think I implemented in a way that was just make it easy to make silly mistakes. But that said, let's go over this problem. And the idea is that you don't want to. So the naive solution may be that, okay, you start at one node and then you just go through, do a depth first search or any search, and then kind of try to find these cycles. If you could kind of imagine it as, because there's only one going edge, you can almost think of it like a linked list if you start at the beginning, right? And that's basically the idea, except for that there are some nuanced case. The one case that I legitimately got wrong answer and I just forgot is that you can start a cycle. But yeah, let's go over the code real quick for that. I know the explanation's a little bit short, but I think that this one is, pretty doable, except for that it was very sloppy. But yeah, here I just try to go for the edges to see which edge has in degree of 0, right? So now, and here I will go, okay, if this in degree 0, that means that you can think about it as you could start a test here. And that's what I do by going here. I start, I keep track of the time, and the time is important because and I think that another way that I could have done it, but I didn't do it this way, is by using coloring. This idea that you first color it, one color, and then you just do it by checking another color. But I didn't do it that way, so that was very sloppy. I kind of tried to invent my own thing and hacky because I was very really not like I was not very sharp with respect to known literature. This is a known literature problem about that first search. So maybe I'll even do it live in front of you. But I want to go over this quickly. But the idea is that, okay, if the in degree is 0, then you can think about it as the linked list finding a cycle, and then you do it. Otherwise, so after you do all those, keeping in mind that we keep track of this done so that we don't kind of loop into things. And one thing that I think I just did was rushing it because I was solving it for a more general thing. Is that we don't do duplicate work on the things that we've seen before, meaning previous loops, right? Because if you think about this as like almost like multiple linked lists merged together, then if you go to another linked list, then like if you cut in the middle, then you already know that you'll get the same answer as before. So in that sense, you won't have to do it again, right? So that's basically the idea, and that's the idea of this done. Though again, you should maybe do it with coloring. And at the very end, I have this thing where I have to do it again because now we don't keep it. If you think about the linked list analogy, we do the linked list, but then we don't keep track of the cycles. Where what I mean by that is you go in, and then you go in, and if you have a cycle, there's no node with an in degree of 0, and you have to take care of it. So then you have to just if it's still not done, then that means that there's a cycle because all the heads of other linked lists is already done. So we just go through it, and yeah, that's pretty much it. I had 3 silly mistakes, which is kind of sad. One is the cycle one, which maybe is a legitimate one. The second one is just that I didn't because this returned early, I forgot to mark it as done, so I didn't change the colors correctly. I should have done this another way, but I was trying to fix it. And then the third silly mistake is that I actually got the example case wrong, so I was just off by 1. I was returning 2 because I don't know. I think I remember the output from the previous problem, and I thought it was going to be 2 and it'll be okay. But the answer is actually 3, and I just kind of, well, I mean, I could have just misread it. So that was a very, very silly problem. I did this in about like 13, 14 minutes, or maybe 15 minutes. Not that short, but also not that long, and also like 8 or 9 minutes of that time is debugging. So that's very sad. Let me yeah, and this is going to be linear time because we look at each node at most once ish, so, or twice if you want to go by the Kali analogy, but each node will look at constant amount of time. So this is going to be linear time, and it'll be fast enough, and of course linear space. All right, let me try to solve this in front of you as an up-solve, in that, maybe I'll try to do it cleanly now. Now that I think through the problem a little bit longer, I definitely had an element of just rushing it because I knew I was a little bit slow to get a top score, so I was rushing it, and so I don't know. It is what it is sometimes, but yeah, let's see. So I think this part is okay, but what I would have done is this idea of color, right? And I think that's the more canonical way of doing it. I forget what colors are good, but basically you have black, white, and gray. It doesn't really matter what the numbers are, but the idea here is that you only go if, yeah, I think we don't even need this. I think one thing that I did not realize is that maybe we don't even need this degree thing. I thought before that we needed it because I was trying to be cautious about it, but I think we actually don't need it. We can just do something like, like this. Well, if colors is equal to right, and that should be good, to be honest, with the same way. And then now we do the recursion here, we do the local for time, and that's fine. And what I would like to do is maybe go yeah, and this could be done with a while loop as well. Doesn't have to be recursion. So let me try to do it that way. I think that's the way that I would have done it. But yeah, maybe just quite fine. Maybe that's a terrible name anyway. But in any case, yeah, because you can really add to your thing. So I think this should be good, because and the reason is because there's only one there's only one out degree for each node, so that's why this is good. But here we can actually maybe even get rid of this global timing thing, and instead maybe that's fine. I don't know, because then we have to allocate memory here n times, and you don't want to do it by accident, to make it n square. But the idea here then is that, okay, no, wait, what did I delete it by accident? Okay, fine. Just do we could just do it with a lookup table then, right? So then now let's do it with a while loop, and then we have, let's just say, maybe even with a scene loop, right? And then now we can do something like while x not in scene, current is equal to 0, say. Then now we process it, so we do time of x is equal to current, scene. I guess we don't need scene, we just do the time. Yeah, and then now x is equal to, oh, maybe I could just do this. Let's just do start, and then this is x is equal to start. So then now we have that in the future, but x is equal to edges of x, and x is not equal to -1, because if it's equal to -1 we break. But and then here now if x is equal to -1, we should return. I mean, we're returning, but we also want to just color everything, right? So let's just do a thing x. Maybe I could have done it this way, and it's just a little bit more robust. Maybe, oh, this is start. And then we return. Otherwise, then we know we best is equal to max of best, and then it's time of x, which is the last element seen. Oh no, the current. I have to increment. So then it will be the current time minus time sub x max absolute of this, just to be sure, and then plus 1. I think that should be roughly good, assuming that we have color, which oh yeah, and here we do want to add that if I guess it doesn't. Trying to think about optimizations, and I'm even slow here apparently. Yeah, and basically, and the color of x is not equal to black, because if it's black, that means that we've already done it on a previous loop, and we don't have to worry about it. I guess in theory, I'm supposed to do something like color of x is equal to gray, but I guess now that we're doing it not recursive, I guess maybe it doesn't matter. But then here we do the same thing, which is while yeah, let's just have scene is equal to set while x not in scene, colors of x well, and here, well, actually we want to color both anyway. Yeah, maybe this is just wrong, but nonetheless, black, and then that's it. X is equal to edges of x. And then that's maybe it. I feel like something's a little bit off here though. Or maybe maybe I don't need this. I need while colors of x is not black, we do this. And that's roughly right. Maybe I'm wrong here. Did I misspell color somewhere? Oops. I keep on saying colors and colors in different places. Huh. And that's a typo. Yeah, we'll do it. Oh, this is. Why is that an error? Oh, because we go to the next one. Okay, well, I guess if edges of is equal to -1, then we break. And that means that there's no cycles, right? So that's why we can go ahead of time. But that's weird. Oh, because if it's black, then we terminate. I meant to do that one, actually, check that one. I mean, okay, that makes sense, but zero. Which one is this? Yeah, apparently, even knowing the answer, I'm going to be slow. So maybe I just need more practice or something. 0, 3, 2, 4. Yeah, that sounds right. Why is the 3 not in there? Oh, because of the 1. 1 is next. So yeah, maybe I'm off by 1. So 1 is 9 times. Okay, so it is black then. that we should color with. So okay, that is terrible. Okay. Well, yeah, after you color it, of course it's going to be done. But you still, this is a little bit messier than I expected, to be honest. Okay. Maybe I don't need the +1 in this case. Because at the current time we incremented it, so that's why there's already a +1 before we loop out. I think there's another one where it's like 2 to -1, and then there's just like a cycle one where maybe they look on each other. Edges. Oh, so there's no sub loop. Alright, fine. Okay, let's give a quick submit just for funsies. Hopefully no wrong answer. Okay, yeah, so I think this is the colorway. Maybe recursive is the way to do it, but yeah, that said, doing the contest, I think it's just about just sloppy. Like, I think I got one wrong answer and that's fine. That or it's fine in the sense that like I legitimately forgot about it. So you know, but the two other wrong answers were just sloppy on coding. I'm a little bit sad about. So anyway, same algorithm, and apparently I didn't need to. And the thing about the loop is that I think if I spend more time on the math and theory, and this is something that a lot of people practice on, but I've forgotten about it, so I'm a little bit rusty about it. But is that I would have known that if I thought it through a little bit longer, then I would have known that it didn't matter the in degree thing. And if I knew that it didn't matter the in degree thing versus just do it on every number or every node, and then and that they all connect to the same node, then I wouldn't have made that mistake. So in that way, I just need to be better. To be frank, I know it's been like just like I do okay on the first 3 Qs, and then I just Q4 has been beating me up lately. So yeah. Anyway, that's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye. No silly mistake, please. Okay, fine. Okay, we already got this, but that's fine. Got the 3 parts, right? Okay, how do I do it? This is just a literature problem, but this is what it sounds like. People are way fast, but that's because I was slow on the other one, I guess. Three is good, one is not so good. Why is it not so good? Oh, because that's not a cycle. We do it backwards. So it shouldn't. That's weird though. Why is that one? Because it's not equal to infinity. Oh, because of -1. Okay, fine. I don't know if that's just right even then. Why is that one? So this is kind of wrong. This is definitely wrong, but 2, 2, 2, 2. So 2, 2, 3, 3, 1, 1, -1. So why is that returning a 1? Oh, because of this one. Oh, actually, I need to do something which is if this is -1, then this is a leaf and we're good. Otherwise, but this isn't right because you can have something like let's see. I guess just 2, 2. I think this is a known problem that people know, but I have to do it from scratch. This is going to give me a 1, but that's not right either. So we want to do something that we've seen before, but done. Okay, I guess maybe we do need done as well. guess we just do some color thing. Oh. Oh, it goes. Okay. Give it some YOLO. Shake you on about this one. Oof. Kind of YOLO'd on this one, but that's fine. Because I feel like I had to be YOLO to get a good score, but 3 is that 0, 1, 2, 2 is to 4, 4 is to 2, and then 4 is to 3. So then my output is 3. Why is it? Did I misread it? 0, 1, 2. Oh, I misread it. So the 0, 1, that's 2 is at 3, the 2 points at 4, and then the 3 points at 2, and then the points at 3. Okay, so that is a 3. Why did I get a 2? I mean, I should have done it maybe in a cleaner way, but that's okay. So 0. I'm gonna go to 3, 2, 4. Yeah, and then they're all done. So then why is that 2 instead of 3? Because this is 0, 1, 2, 3. Let's see it. Yeah, so this is 1, 2, 3, 4. So 2, 4. Did I mess up my loop? Why is the first one right then? Because these are the time. So if there's time, there should be +1. But then the first one is wrong then, right? Oh no, the first one is right. Why is that? How is that right on the first time before? Did I just get lucky? Oh no, the answer is 2. Oh, the answer was 3. I just misread the answer altogether. So this is, oh, this is the input. Wow, I am very dumb today. Yeah. I mean, I misread that. Okay, well, you should at least get the input, the example cases right. Okay, now it's wrong, but that's fine. But that is just a dumb 5-minute mistake. Okay, let's see. I returned -1 because I don't think there's a possible answer, but there clearly is a possible answer. So, and we always see a 3 thing here. So 0 goes to 1. Oh, in this case I don't ever go in because none of the degree is 0. Okay. So then now, okay. Oh, maybe I am just a little bit silly today. A little bit YOLO. I really don't know this one then, maybe. I feel like this is a well-studied problem and a lot of people have gotten it, but this is not my, like, people know how to do this one, but I don't really. Should I just Google? I mean, this is just impossible to kind of dig into as well. The output is 45 seems a little dubious. Oh, because I'm looking at the timing, and this might have just... done some stuff, but yeah, I think yeah, this doesn't really make sense because now because now there are a lot of loops and we're counting things not into the same loop, because now how do I fix this? Okay, so we have 0, 2, and then seems like the time is all settled on the first go. Is that supposed to be right? Oh no, that's because it's going into the second cycle thing. But why is it like not done if it has a time? Did I mess it up? Did I return somewhere? Maybe it's this. Just because if we've seen a done edge, then we have to return it. Okay, fine. That's just me being sloppy. Because so I want this operation to be done after, but not including this. But okay, let's just give it another submit. At this point, I'm expecting another wrong answer because I've just a lot of silly mistake, to be honest. Not super. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. Stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye.